So now I want to look at a special case. So for this, let's assume that we have two vectors u and v. And let's assume they are non-zero vectors. Suppose that their dot product is equal to 0. What can we conclude? Okay. Well, let's use what we know about dot product and angle. We know that the dot product of u and v is going to be equal to the norm of u times the norm of v times cosine of the angle between them. Now, if u dot v is 0, then that means norm of u times norm of v times cosine of theta is equal to 0. Notice that all three of these are just being multiplied together. And what do we know when we multiply things together and get 0? The only way you can multiply numbers together to get 0 is if one of those numbers is 0. So either norm of u is equal to 0, or norm of v is equal to 0, or cosine of theta is equal to 0. But what was our assumption at the beginning? We assumed that we have non-zero vectors, which means they have length, right? Specifically, that means the norm of u cannot be 0. It's not a 0 vector. Norm of v cannot be 0. It's not the 0 vector. So that means the only thing that could be 0 is cosine of theta. So cosine of theta must be 0. If we have u and v are non-zero vectors and the dot product of them is 0, then the cosine of the angle between them must be 0. Because theta can only go between 0 and 180 degrees, the only theta for which this would be true would be theta equals 90 degrees. Which means if the dot product of two non-zero vectors is 0, guaranteed they are perpendicular to each other. So u and v must be perpendicular to each other. Okay? And this is if u and v are perpendicular to each other, then this must be true. The dot product of the two vectors must be 0. So this gives us a really easy test to determine if two vectors are perpendicular to each other. If the dot product between them is 0, then they are perpendicular. Okay? Now, we actually expand upon this idea just a little bit and introduce a new word. So let u and v be an Rn. We say vectors u and v are orthogonal. If the dot product is 0. Okay? So a really good question at this point would be, why are we introducing this new word? Perpendicular was a perfectly good word. Why are we introducing the word orthogonal? So in most situations, at this point in the course, they're going to mean the same thing. All right? If the dot product of two non-zero vectors is 0, then the angle between them must be 90 degrees, so geometrically they must be perpendicular. Notice the definition here is just a hair broader because we do not make the assumption that u and v are non-zero vectors. So we would say u and v are orthogonal if their dot product is 0, even if one of those vectors is 0. Okay? So in most instances, orthogonal and perpendicular are going to be about the same thing. Orthogonal means just a little bit more. And later on in the course, we're going to generalize the idea of a vector space to regimes that do not have a clear geometric interpretation. In that case, we will have something like a dot product there, and we'll also use the word orthogonal, even though, because it doesn't have a geometric interpretation, perpendicular wouldn't make sense. So orthogonal is just a little bit broader of a word. At this point in the course, perpendicular and orthogonal are just about the same thing. But if you want to sound fancy, use the word orthogonal. That's going to be the word we will usually use in this course. So that's approximately the same thing as perpendicular, especially at this stage in the course.